Question 6, this is a crossover question. We did this one on the foundation paper last Sunday. So the table shows information about population of a city. So from 2001 to 2011, the population went from 420,000 to 480,000. Then Liam is working out the population increase. So he did 480,000 minus 420, which gives him an increase of 60,000. So that increase is correct, because if you subtract them, you're going to get 60,000. And then he's working out the population in 2021, which is 10 years. The next 10 years. Now, assuming that the population is increasing by the same percentage, because that's what the sentence says here, it will increase by the same percentage, then it means that from 2011 to 2021, it's going to be 60,000. That's going to be the increased amount. So for this question, for 3 marks, you need to work out the percentage change. So the change, which is already there, is just 480,000 minus 420,000. And that gives you the 60,000. That is your change or the increase. Okay, so the same thing as the increase. So to get the percentage change from 2001 to 2011, we're going to put 60,000 over the original, and the original figure was 420,000. Okay, so we're going to put that over 420,000, and we times that by 100 to get the percentage change. Now if you put that on the calculator, remember it's a calculator paper, so just put that on the calculator, you're going to get 14.3%. So that's the percentage change from 2001 to 2011. Now we're going to do the second percentage change from 2011 to 2021. And assuming that is going to be increasing by the same amount, we're still using the 60,000 here for our increase. So 60,000. And now our new original amount is going to be the figure from 2011. So it's going to be 480,000 in your denominator. So 480 in your denominator, and then times that by 100. Pop that in the calculator, and you should be getting 12.5%. Now we can compare both, okay, and we can see that the percentages are not the same. So to answer the question, does the population of 540,000 match his claim? And that's going to be a big no, because the percentages are different. Okay, thank you guys so much for the likes and the shares and the follows. Much appreciated. Different percentages, okay? So that's a no for 3 marks. Question 7. On 3 days, Ali throws darts at a target. Here are his results. So this is another crossover question that came up on the foundation paper. So the question asks us to work out 2 different estimates for the probability of Ali hitting the target. So if we're looking for the probability of him hitting the target, then we're going to look at the table that says number of hits, the column that says number of hits, and the column that says number of throws. Those are the 2 we're focusing on. Now for this particular question, you could write down multiple options for your probability, okay, but you only need 2. You could put 15 over 20, 22 over 30, 17 over 40, 54 over 90. You could even add 2 of the number of hits and put it over the total. So you could have multiple. So I'm just going to write down first few. Let me just pick 3, any 3. So it could be 15 over 20 as 1. It could be 22 over 30. It could be 17 over 40. Or you could have 54 over 90. Okay, etc. So you just pick any 2. Alright, so I'm going to use 22 over 30. and I'm going to use 54 over 40. 54 over 90. Okay, so you could pick any two of those, guys. Any two. Now, part B says, which of your answers is the better estimate for the probability? So, because the denominators are different, the two that I chose, they have different denominators, then I'm going to have to make them a common denominator. Okay, so let's make the denominator the same. So we have 22 over 30. I'm going to get that to be a denominator of 90. So I'm going to multiply the top and the bottom by 3. So that's going to be 66 over 90. And I'm comparing that with 54 over 90. Now we're looking for the one that is closest to 1. Okay. That's going to be the most accurate one. The one that is closest to 1. And we can see that 66/98. That's closest. So that is going to be the better estimate. Here. So we use 66 over 90. So 22 over 30. Let's put that. And the reason, you can put more throws. Something like that. Okay. No, I'm not in school tomorrow, guys. We only had maths intervention. Monday, Tuesday, Wednesday. Okay, so that's 7B. Question 8. Theo starts with savings of £18. Another crossover question, guys. So if you were on the live on Wednesday, you would have seen this question before. So we're going to do it in two sections. So we're going to do Theo, and I'm going to do James, and I'm going to use repeated addition for this question. So for the first, or week 0, because that's what they're starting with, Theo started with £18 and James started with none. Now every week Theo is going to save £4.50. So you just keep adding on £4.50 continuously. And then for James, he saves £4 each week. So you keep adding 4 each week. So let's write down for James. So 4 multiples of 4. So 4, 8, 12, 16, 20, 24, 28, 32. Let's stop here. If we need to fill in others, we do that afterwards. So for Theo, I'm going to add £4.50 each time. James, we added £4 each time. So adding £4.50, I'm now at £22.50, 22.5. Then we add another £4.50, 27. Keep adding, 31.5, 36, 40.5, 45, and then we have 49.5 here. We can stop. So we're going to pick the two numbers that is going to simplify to the ratio 15:8. Look if you can spot the pair, guys. The one that's going to simplify 15:8. Which two numbers are we looking at? 15:8. It's going to simplify to 15:8. All right, thank you, Callum. 45-24, definitely. Okay, so if I have 45-24 and I'm going to simplify that, then it means I'm going to find the HCF, which is going to be 3. So if I divide both of those numbers by 3, it's going to give me 15 and 8. Okay, so if we started at week 0 with £18 and £0, then week 1, 2, 3, 4, 5, week 6. Okay, so your answer is going to be 6 weeks. 6 weeks, guys. Thank you, guys. How do we know? So you have to look at the one that has a common factor, which is going to simplify it to 15:8. Thank you, Amanda, for the roses. Much appreciated. So you look at the pairs, look at the pairs here, and you're going to look for one that has a highest common factor, which is going to simplify it to the ratio 15 to 8. Thank you, Amanda. Much appreciated. Question 9. The length of each side of a regular pentagon is 8.4 to 1 decimal place. So we have a number rounded to 1 decimal place to give us 8.4. So we want the error interval. So you're writing down the number before you round it. Or we're writing down the range of numbers that before we round it, okay, gives us, when we round it to 1 decimal place, it gives us 8.4. So for this, the degree of accuracy is 1 dp. So you're just going to increase your number by 0.1 and decrease it by 0.1, and then you find halfway between. So 1.1 less than 8.4 is 8.3, and 1 above is 8.5. Now you find halfway between those two. So halfway between 8.3 and 8.4 is 8.35. And halfway between 8.4 and 8.5 is 8.45. So that's your error interval. Yes, this is a crossover question. Okay, so part B says to work out the error interval for the parameter. Now to do the error interval for your parameter, you need to look at what is given here. Okay, so we're going to do the lower bound for the parameter. And then we're going to do the upper bound. Okay, so we're going to do the lower bound for the parameter. So using the lower bound, which is 8.35, because it's a pentagon and it's regular, all the sides are equal. So you could just do the upper bound. Lower bound 8.35 multiplied by 5. Remember, multiplication is repeated addition. So instead of you using the calculator to do 8.35 plus 8.35, doing that 5 times, just multiply it by 5, and that will give you 41.75. And that is going to go here on your line for the lower bound, 41.75. And then to do the upper bound for the parameter, you take the 8.45 from part A, multiply it by 5, and then that will give you 42.25. For 1 mark, guys. Feel free to use your calculators. This is a calculator paper. Okay? Thank you guys so much for the likes and the shares. Question 10. Volume of a sphere is 4/3 pi r cubed. Why do we times it? Because it's a pentagon and it's regular, so all the sides are equal, and there are 5 of them. So if each side is 8.35, so you just multiply it by 5 because they're equal. Okay? Question 10. So we're going to work out the volume of this hemisphere. So the volume of the hemisphere is going to be the volume of the sphere divided by 2, because this is half of the sphere. Okay? So we're going to do 4/3 pi r cubed, and then all of that we divide it by 2 to get the volume. Let's substitute. So that's 4/3 times pi. The radius is 30, so that's 30 squared. And then divide all of that by 2. Just put all of that on the calculator, because it's a calculator paper. Why do you divide? This is half of the sphere. Oh, cubed, sorry. Not square, guys, cubed here. Okay, cubed in the formula. We divide it by 2 because this is half of the sphere. Okay? So put all of that on the calculator now, guys. And you should be getting 56,548 0.67 centimeters cubed. Okay? Be sure to use your brackets, just as how I write it down here. Open brackets and put in everything, close the bracket, and then divide it by 2. Or if you have the fraction bar on your calculator, you can use the fraction bar. Okay, so sand fills the container at a rate of 4,000 centimeters cubed per minute. Does it take less than or quarter of an hour? So we need to find out how many lots of 4,000s are in 56,548. So we're going to do 56,548 divided by 4,000 now to work out the number of minutes. Put that on your calculator and you should be getting 14.14 minutes. Now the question asks you, does it take less than quarter of an hour? We know 1 hour is 60 minutes. And if I do a quarter of 60 minutes, that's the same thing as 15 minutes. Now comparing these two, the 15 minutes and the 14.14, we can see that 14.14 is less than 15 minutes. Now because it's less, then your answer is going to be yes. Okay? So it's going to be yes, guys. It takes less than quarter of the hour. Okay. Question 11. 2 ordinary fair dice are rolled. Complete the tree diagram. Probability is out of 1. So if the denominator here is going to be 3, then it's going to be 3 out of 3, which is the same thing as 1. So if this is 1/3, then this is going to be 2/3. And you repeat the same thing over here and fill in the diagram for easy 1 mark. Okay, that's 1 mark. Abigail, this is higher, but these are some of the crossover questions. That is also on the foundation paper. Work out the probability that both dice land on a number less than 3. If we're looking for less than 3, we're looking for this branch of the tree diagram, 1/3. And over here, both has to be less than 3, 1/3 and 1/3. So you're just going to multiply those two. 1/9. Why is it 3/3? Because probability is out of 1. The chance of something happening is out of 1. So when you do probability, your probability can range from 0 to 1. Anywhere between 0, from 0 to 1. Okay? So because this particular fraction is out of 3, that's why I put 3 out of 3 there. So you can see where the 2 comes from in the numerator. Why you times and not add? Because it says the probability both of them will land on the less than 3. So it's 1/3 and 1/3. So if you roll the two dice, you're looking at you rolling them at the same time. Okay? So it's going to be a third on one dice, third on the next. So it's going to be a third and a third. So you have to multiply. Question says, work out the probability both lands on a number less than 3. Less than 3. So you have to use a third. This one and a third over here. Okay. Part C. Work out the probability that exactly one of the dice lands on a number less than 3. So the 2 dice are being thrown and we're going to look for the combinations that has exactly 1 that lands on a number less than 3. Okay, so let's go back to the diagram and we're going to look for those branches that has exactly 1 that lands on a number less than 3. So if we look at the first branch, we have 1/3, which is less than 3. Okay, so we need this here. And it says exactly 1. So we can't use less than 3 again. So it has to be 3 or more this time. Okay? So this is 1 that has less than 3. So that's the first one you're going to use. And the second one, less than 3 is here. This one has less than 3. And that goes with 3 or more. Okay? So out of these two, you have to have it one time. Once. Here. So that's 1/3, 2/3. And because we have two possible options here, this is where your or comes in. Okay, and in this case, you're going to be adding. So it could be this one or the one at the bottom, 2/3 and 1/3. So this is 2/3, 2/3 plus 2/3. Okay, 2/3 plus 2/3, and that gives us 4 over. No, not 3, 9 at the bottom. Okay, remember it's multiplication, guys. 3 times 3 is 9. 3 times 3, 9. So this is 4 over 9 now for your answer. 4/9. 4/9, guys. Okay, so you have two possible options. This one or the one at the bottom. So you have to add them. Okay, question 12. This one asks us to work out the gradient of a straight line. Okay, so gradient, whenever you do gradient, it's going to be the change in y divided by the change in x. So on your line, you're going to pick 2 points and you're going to draw a triangle. So I'm going to use this point here in the corner of the grid. And I'm going to use this one here in the corner also. So go ahead, draw the triangle. So you can count the change in y, the change in x. So the change in y is going to be 2 units. And the change in x is 1, 2, 3, 4. 4 units. So your gradient is going to be 2 over 4. Which is the same thing as half. And that's for easy 1 mark. This is higher, pumpkin. These are the crossover questions that came up on the foundation paper too. So these are like the grade 4, 5 questions. Okay, the grade 6, 7, 8, 9 questions are towards the back of the paper. They're coming up. Okay, part B. In fact, the scale is 1 centimeter to 2 units. Okay, so if the scale is increased by 2, okay, then it means then that the change in y and the change in x is going to be doubled. Okay, so we had 2 over 4. That was the original one, 2 over 4. So if it's doubling up, the scale doubles it up. So the gradient now is going to be 4 over 8. And 4/8, guys, is the same thing as half. So the question is asking you, which of the statement is correct? Is the answer to part A too big? Is the answer to part A stays the same? Is the answer to part A is too small? So it's going to stay the same, guys, because we can see that from our calculation, we still get 1/2. Non-calculator, we did that one last week. S. We had the replay yesterday for the non-calculator. I'm working on the YouTube video, guys, so I'll be uploading those to my YouTube shortly. I just want them to be clean, so I'm definitely working on those. Question 13. Show that x is not equal to -1. We're going to use this fraction here. So this is a higher question now, guys. And we're going to write it in the form ax plus b, where a and b are integers. So if I have 8x squared minus a being divided by 4x plus 4. To get it into the form ax plus b, I'm going to have to factorize. Okay, so for this one, we need some factorizing here. So this is algebraic fractions. So let's go ahead and factorize. Let's factor this out. So if we look at 8x and 8, the common factor there is going to be 8. So you're going to open bracket, x squared minus 1. And then in the bottom, the common factor of 4x and 4 is 4. And in brackets, x plus 1. Now to further simplify that, the bracket at the top, the x squared minus 1, that's the difference of two squares. Because 1 is a square number, and if you do x squared, that's a square number. So this is difference of two squares. So to factor that out, you need two brackets. You're going to need x in both. You're going to need a plus in one and a minus in the other. And we know that the square root of 1 is still 1. So that's x plus 1, x minus 1 when you factorize that out. Okay, x plus 1, x minus 1 when you factorize the bracket at the top because it's difference of two squares. So let's go ahead and write that in and simplify our algebraic fraction some more. So that's 8, open bracket, x plus 1, x minus 1, close brackets, over 4 in brackets x plus 1. Now, all of these are multiplication at the top, multiplication at the bottom. The bracket signifies multiplication, so we can cancel out now. 4 goes into 8 2 times, and x plus 1 cancels out x plus 1. So at the top of your fraction, you're going to be left with 2 in brackets x minus 1. And you can expand that bracket. So we're going to do 2 times x, which is 2x. 2 times a minus 1 minus 2. Now that looks like this now. Our ax plus b. Now I've been asked questions before. Miss, we got a minus in the answer. Why did they have a b here? Now the reason for that, when you do a negative times a negative, it gives you a positive value. Now, if they had put a negative here in the expression ax minus b, then this negative 2, which is the value of b here, multiplied by this minus here would make it a plus, okay? But the value of b is not a positive, it's negative. So that's why they used plus instead of minus. So we know that a positive times a negative, it still gives us a negative, okay? So this plus is not going to affect this negative 2 here. Foundation is on Sunday, guys. 7 p.m. So that is it, guys. Now, if 2x minus 2, if that's 2x minus 2, if I put input x for negative 1, let's see what happens when I put x for negative 1. If x is negative 1, let's input that. So we're going to do 2 in brackets, negative 1 minus 2. So 2 times a negative 1 is going to be a negative 2 minus 2, which is negative 4. Okay? So this is how you show. That's what they're looking for. All right, 3 marks. Question 14, loci. If you have your exam paper printed and if you have a compass, feel free to use that. But for the purpose of me using the tablet, I won't be able to use the compass on the tablet, but I'll tell you exactly what you need to do when you get loci question. So the scale drawing represents a garden. Okay, so this is a garden, and there is a water sprinkler, which is at P, and there is a water sprinkler at Q. Now, the water sprinkler at P reaches up to 20 meters. Okay? It reaches up to 20 meters, the one at P. Now, we're going to use the scale given and to convert that into centimeters. Okay? Because in your exam, you're going to use your ruler and you're going to need to use the centimeter on the ruler. So let's convert 20 meters to centimeters. So 20 meters, you're going to do 20 divided by 5, which is 4 centimeters. And this 25 meters, let's convert that to centimeters. So your 25 meters, just 25 divided by 5, which is 5. So these are the two measurements that you'll be using. So you're going to take your ruler and you're going to have to open the compass to 4 centimeters on the ruler. 4 centimeters on the ruler. That's what you're going to have to do. Now, once you have the 4 centimeters on the ruler, because it says the water sprinkler reaches up to 20 meters, you're going to have to draw a circle at each of those points. So at P, when the compass is open to 4 centimeters, you're going to put the compass at P and draw a circle. All right, let me use the shape function. And I can input. Let's see. Put it over here. Put it on the side. Okay, I have to use my free hand. So at P, put the compass there, and then you're going to do a circle. So your circle will look something like that. This I'm just using my free hand. Okay? And then at Q, you're going to open the compass to 5 centimeters. Open it to 5. And then you're going to draw the arc so it intersects this one here. So when you put it at Q here, it's going to give you a nice circle intersecting this one. Something like that. Okay? This is higher, guys. Now, where they intersect, this is where both sprinkler reaches, here in the middle. So you shade this part here. Okay, so you open the compass to 4 centimeters, put it at P, draw the circle, open it to 5 centimeters on the ruler, put it at Q, draw the circle. 2 marks. This is loci, recreational, loci. Or some people say locus, 1, loci. More. Okay, number 15. 100 men and 100 women took a test. The median is given as 28 and 30 respectively. Interquartile range 7.59, and then we have 31, 37. Use this data to tick the statement that must be true. Okay? Now, it says men had a higher average score than women. Men had more consistent scores than women. A woman had the highest score, and a man had the lowest score. Now, the only average that we have here is the median. So this is the average. And the interquartile range and the range, those are measures of dispersion. So it's just basically how wide the data is spread. These two are the spread of the data, the interquartile range and the range, okay? So the interquartile range is the spread from the lower quartile to the upper quartile. So from the lower quartile to the upper quartile, that's the interquartile range, how wide the data is spread. And then the range is from the biggest to the smallest value. So if they're talking about average score for the first one, we're looking at the median, okay? And we definitely can see that the women, they had the highest average score here because they had 30 and the men had 28. So it can't be this one. Now, if we're talking about the consistency of the score, you're looking at how closely packed the data is or how close the numbers are together. And for that, you need to look at the range, okay? So we're going to look at the range for this one. And this one is the median we just did. So the range tells you how wide or how closely packed the data is. Now, looking at the range here, we can see that the women, their range is wider. So it means that their test scores, they're more spread out than the men. Okay, which means that the men had a more consistent test score. So if the range is small, then it means that the men, they had the more consistent test scores. Okay, because they had 31 and the women had 37. And we don't have any frequency here. So we can't talk about the highest score or the lowest score. Okay, they didn't give us any, and they didn't give us the upper quartile or the lower quartile. So we can't do these two. So it's going to be the second box for range. Thank you guys for the follows and the likes. So you have to understand what the range means and how it affects the data. Okay, and also average. So remember, you only have 3 averages: mean, mode, median. Okay, so the only average here is the median. These are the spread for the data, interquartile and the range. All right, question 16. Some concrete has volume 3.8 meters cubed. The density of the concrete is 2,400 kilograms per meters cubed. Work out the mass. Okay, so you get questions like this in science too. Density, mass, volume, speed, distance, time, area, force, pressure. You need to remember those formulas for your GCSE. They won't be given to you on the formula sheet. So it's definitely something that you have to remember. So most kids, they prefer to write down the triangle like this because they're able to memorize it that way. So for your mass, density, volume, M goes at the top, D over here, and V on the right. What that means, to get your mass, you're doing density times volume, okay? So you're multiplying. So mass is density times volume. So if the density here is 2,400, we're going to multiply that by the volume, 3.8. Put that on the calculator, and then that will give you your mass. Thank you, Coffee. 9,120. Excellent. 9,120 grams. And that's an easy 2 marks, guys. Easy 2 marks. Part B. Part B says the 3.8 meters cubed of concrete is made into shape of a cylinder. The base has a radius of 0.5. We need to work out the height. So we don't know what the height of the cylinder is. So part B, we're going to use what we got from part A up here to help us. Okay? So volume of a cylinder, that's a formula you need to remember. It's going to be the area of the base times the height. Okay? So volume, and the base is a circle. So it's going to be pi r squared times by the height. Pi r squared times by the height. Okay, let's substitute. We found the volume to be, or it was given to us, because this is from the part A of the question. It says 3.8. So we know the volume is going to be 3.8. That was given to us. And that is equal to pi times the radius, 0.5, squared times by the height. That's what we're trying to find. Okay, so if you do 0.5 squared, that's going to be 0.25. So this is 0.25 pi times by the height, and that gives you 3.8. Now you're going to do inverse now. Inverse of multiplication here, which is to divide both sides by 0.25 pi. Divide both sides by 0.25 pi. Just punch it on the calculator, and that will give you a final answer. So the height is, put this on the calculator. Your height is going to be 4.84 meters. Is this year 8 work? Remember, your GCSE is everything that you've done in secondary school, even stuff that you've done from primary. So it tests everything that you know in maths. So you find that a lot of these stuff that we're doing, some of them, you get them in year 8, year 9, year 10, it depends. Okay, so you find that the GCSE paper has all the topics. Yes, so it's a mixture. Okay, so this is for higher paper, guys. Number 17. So a ball is thrown vertically upwards, and the graph shows the height of the ball above ground after it's thrown. So part A of the question says, for how many seconds is the ball at a height of more than 2 meters? Okay, so for a question like this, you're going to have to use your ruler, and I'm just going to draw it on so you guys can see it. So if we're looking for how many seconds the ball is at a height of more than 2 meters, okay, more than 2 meters, so we're looking on the y-axis because that's the one labeled in height. So 2 meters is here on the y-axis. So you're going to have to take your ruler and draw a line across from 2 until it touches this curve. Let me straighten it up. And then you're going to, at that point, you're going to draw a line down to the x-axis here. So we can see that that's going to be what? 3 seconds. Okay, so this is 3 seconds. Just like that, 1 mark. Okay, see if you can spot the answer for the second one, guys. Drop your answer in the chat. Go ahead. Drop your answer in the chat. See if you can spot it. Okay, 1.5, 1.5. Excellent, guys. So for after how many seconds is the ball at an instantaneous rest? So for the rest, you're looking at where the graph is flat. And the only flat bit I can see here is at the top. Okay, so take the ruler. You're going to draw a line at the top for the rest. Okay, that's the rest at the top. And then you're going to come down to the x-axis and read off that value. And we can see that that's halfway between 1 and 2. So that's 1.5, definitely. Excellent, guys. Okay, guys, power tap your screen for me, please, so we have more people joining. Power tap. Thank you guys so much. Just power tap, power tap. Thank you guys so much. All right, which takes us to question C. Work out the average speed of the ball when it is moving downwards. Okay, so we're looking at the speed of the ball when it's moving downwards. So we're looking at the movement. When it's going downwards, guys. Okay, so that's what we want. The movement downwards. Okay, so speed. Let's work out speed. Speed is going to be, and you need to remember how to calculate speed. Let me draw in the triangle. D at the top, S, T here. So this is another one you need to remember. So to do speed is distance divided by time. Okay. Now time is going to be 2 seconds. So at 2 seconds, it's going to start to go down. Okay. Because we're at 1.5 here. So it's going to start going down. The graph is going to start going down at at 2. And the distance here is 4.5. We have 4.5 here. That's the height or the distance, height in this case. And at 2 seconds, the curve is going to start going downwards. Okay, so we're using time for 2 seconds. Okay, and the distance for 4.5. So we're looking at how the curve changes. The curve goes up, or the ball goes up. Here, it rests a little bit, and then it starts going down. So at approximately 2 seconds, that's when the ball starts going down. Okay? And at that point, we have 4.5 here. I'm using 2. But for a question like this, because it's a graph question, there are a range of values that they will accept for the answer. Okay, so let's do distance divided by time now. Put that on your calculator. Tell me what you guys get. 4.5 divided by 2. Thank you guys for the likes. Much appreciated. Angel, as I said, there are a range of values that will be accepted. So it's not one set because it's a graph question. If you look at the mark scheme, there are a range of values that is accepted. Okay, so it's fine if we use 2.1 or if that's what you prefer, no problem. All right, let's divide 4.5 divided by 2. Okay, thank you guys. 2.25. Excellent. Thank you, thank you. Question 18. The solution of 3 to the power of x is the same thing as 300. It asks us between two consecutive integers, okay? Which two consecutive integers would the 300 be between? So these are just powers of 3. So because it's a calculator paper, just do 3 to the power of 1, 3 squared. You should know which one is closest to 300. So if you do powers of 3, okay, that will take you to your answer. So 3 to the power of 1 is 3. 3 squared is 9. 3 cubed, 27. Then we have 3 to the power of 4, which is 81. Then we have 3 to the power of 5, which is 243. And then we have 3 to the power of 6, 7, 2, 9. Now looking at these powers of 3, we can see that 200 is going to be between 3 to the power of 5 and 3 to the power of 6. So for the values of x, which is in the powers here is going to be between 5 and 6. For easy 1 mark, you just use your calculator, do 3 raised to different powers, and you will see where 300 is going to be between. Which number 300 is going to be between. Okay. Why did we use 2 seconds? Here on the graph. Remember, we're resting at 1.5. So if you use any number from the after 1.5 up to 2, you would get the mark. Okay? You will get the mark. Because at this point, when it rests at the top, remember we said that this is the rest. Here, at the top, at 4.5, then it's going to start going down. The graph is going to start going down. And it's the same thing as doing gradient. So if you put a tangent to the curve and you draw the right angle triangle and you do the gradient, it's the same thing. Okay? That's how you get the speed. The speed is the gradient of the curve. So it's the distance divided by the time. Question 19. A pentagon is made from a square and an isosceles triangle. Work out the perimeter of the pentagon. Okay. So we have 12, 12, 12. These two sides are equal, which means that my triangle is going to be isosceles. So if I cut this across, separate it like that, I know that each angle in my square is 90 degrees. And if that is 90, then the angle here is going to be 125 minus 90, which is 35. So the angle there is going to be 35 degrees at the base of the triangle, 35 here. Okay? So if that is 35, then it means that the angle on the opposite side over here in the triangle is going to be 35 also, because it's an isoangle. So the angles at the base are the same. Okay, 125 minus 90, and that gives you the angle for the triangle, 35 degrees. For this, I'm going to extract my triangle so you can see what is happening. Because to do the perimeter, we're going to have to work out these two sides here. We're going to need this side and this side to do the perimeter. So we're going to use a bit of trigonometry now. So let me draw the triangle separately so you can see what is happening. So if I take it out, this is 35 here, 35. The base of the triangle is going to be 12. Okay? And we need to work out those missing sides. Let's work out these missing sides here. Now, what do you think we can use to help us to work out that missing side? Because they're equal, so it's going to be the same measurement. What do you think we can use? Pop your answer in the chat, guys. What can we use to help us to work out the missing sides? There are several methods you could use. You could use cosine rule. Yeah, but that one will be long. How about sine rule? Because we could find the angle here. And we could use sine rule. Or we could just use basic trig. Yeah, we could split the isosceles in half. And then use one of the trig ratio, SOHCAHTOA. So there are multiple ways you could do it. Okay? But I'm going to use the sine rule. Just for the sake of practicing the sine rule. If you choose to use the cosine rule, no problem. Okay, so if I'm using the sine rule, I'm going to work out this angle here. So I'm going to do 180, take away 35, add 35. And that's 70, so this is 110. So this angle here is 110. Yeah, you could use SOHCAHTOA. So let's work out this angle here over on the side. So we have 12, or let's call this x. Let me call it x. Let's put x over sine, it's opposite to 35. X over sine 35 is equal to 12 over sine 110. Okay? Say you could use Pythagorean theorem. As we said, there are multiple methods you could use. You could split the triangle down the middle. We could split it down the middle because it's an isosceles, which means that it's going to be 6 here and 6. So if you want to use that method, no problem. You could use that method too. It's going to give you the same answer. Okay, let's cross multiply. And in cross multiplying, we're going to do x sine 110. And that is the same thing as 12 sine 35. Okay, so to get x now, you're going to divide both sides by sine 110. So it's 12 sine 35 divided by sine 110 degrees. Just put all of this on the calculator and it gives you the value of x. And x is going to be the two sides of the isosceles triangle. Put all of that on the calculator and it's going to give you 7.32 to 2 decimal places. Okay? So that's 7.32. And 7.32 over here. Okay? Let's do the perimeter now. So the perimeter It's going to be 12, 12, 12. And then 7.2, 7.2. 7.32, 7.32. Come add up all of those, and then that gives you your perimeter. What did you guys get? Welcome to those who are just joining us. We're going through the higher paper 2 calculator. 50.64 centimeters. How do we know if it's 12 over? When you use the sine rule, it's always, and you're finding the missing side. Okay, it's going to be the side over the opposite, the sine of the opposite angle. So if you look, 110 here is opposite to 12, and 35 is opposite to the x that we're trying to find. So you do opposite side with opposite angle. Now, because we're finding the missing angle, we put that at the top. If you were finding the missing, we're finding the missing side, should say, we put it at the top, the x at the top. But if we were doing the missing angle, then you'd put sine 35, sine 110 at the top. So you could work with them interchangeably. The SOHCAHTOA method. All right, let me make room with this one. All right, so as we were saying, if you split the shape down the middle, okay, we know that this is going to be 6 centimeters and 6. So if I take out my triangle, this is what you're working with. 6 at the base, and this is 35, and then this is the side you try to find, the side on the isosceles. So you're going to label the sides using the SOHCAHTOA. So the angle is here, 35. X is going to be your hypotenuse, and 6 is going to be your adjacent. So the one that you're using, if you're using SOHCAHTOA, is going to be adjacent hypotenuse, which is cosine. Okay, this one, ka. So it's going to be cos 35 equal to the adjacent side, which is 6, over the hypotenuse, which is x. Now the x is in the denominator, so you're going to swap it with the side, the cos 35. So x goes over on the left, and 6 stays the same, and then the cos 35 at the bottom. So to swap it out, because the x is in the denominator. Put all of that on the calculator now, and you should get 7.32. You should get the same 7.32. 6 divided by cos 35. Let me know if that's what you get. Okay. Question 20. How did you get 35 degrees? Here, the angle given was 125. Now, because this is a square, this angle here is 90 degrees. So you do 125 minus 90, and it gives you the angle here, the remaining angle, 35. Okay. Here is an inflated swimming ring with dimensions in centimeters. The volume of the ring is given by the formula. It says to work out the volume when A is 20 and B is 30, and give your answer to 3 significant figures. Okay, so this is just a simple substitution question. So let's substitute in. So volume equal to 0.25 multiplied by pi squared multiplied by, in brackets, B is now 30 minus A, which is 20. And that is being multiplied again by B plus A. So 30 plus 20. Okay, so that's the entire formula when we substitute. All of these here, they're multiplication. Okay, multiplication. So let's simplify that a bit further. 0.25 times pi squared times, what's that, 10 times 50. Okay, so 10 times 50, that's going to be 500. So put that on the calculator, and that will give you your volume. And you're going to round it to 3 significant figures. Okay, 3 significant figures. All right, so if you write down the answer before rounding, it's going to be 1233.7 before you round it. And to 3 significant figure, you're going to cut off at the 3 here and replace the other 3 with 0. So this is 1230 centimeters cubed. Oh, my bad. Why am I always missing the powers? Here. So you need to square that. So this is 100 here, which makes this 5,000. My bad. I'm always forgetting the powers. Okay, so put on that square on the 10. 10 squared is 100. 100 times 50, that's going to be 5,000 here now. And you still get this. Okay, so that is your answer, 1,230 centimeters cubed when you round it to 3 significant figures. So you get 1 mark to do the rounding, guys. So be careful when you're rounding. So this is 1 mark here. You get a mark to do the substitution. And I think you get a mark somewhere in the middle here. So 3 marks. Thank you guys for the follows and the likes. Go ahead, guys, power tap your screen. Share the live for me, please. We're on to question 21. We're almost at the back of the paper now. Okay, so these questions are getting a bit more technical at the back. Yeah, this paper is on Maths Genie. It is. It's on Maths Genie, guys. Question 21. Liz and Tia are walking towards a shop along different straight paths. So Liz, from where Liz is standing or where she's coming from to the shop, it's going to be 80 meters. And we don't know the distance Tia walked to the shop. Okay, so we need to figure out the distance so we can see who arrives at the shop first. That's what part A is asking us for. Okay, so looking at the triangle here, it's not a right angle. We're given 2 sides. We're given an included angle. And we're finding the opposite side to the angle. So that looks a whole lot like cosine rule. Okay, so this is cosine rule. Now the cosine rule states that if you do a squared, it's going to be equal to b squared plus c squared minus 2bc cos of the angle A. Okay, so that's the opposite side and angle. So you're finding the missing side here. Let me call this side A. Let's call it A. And this is angle A over here where Liz is standing. Let's go ahead and substitute, guys. Let me call this B. Call this C here. Let's go ahead and substitute cosine rule. So A squared, that's the side we're trying to find, is equal to B squared. So 60 squared plus 80 squared minus 2 times 60 times 80 times cos 75. So that's your substitution done. So we're going to simplify that. Tadiwa, this is higher, paper 2. We're going to simplify that a little bit more. 6 is 36, so this is 3,600. 8 is 64, so that's 6,400. 8 is 48. 48 times 2, that's 96, so that's going to be 9,600 here. and that is multiplied by cos 75. Okay. Put all of that on the calculator. You can go ahead and do that. 7515.34. That's a squared. Now to get a, which is the distance Tia is going to be walking to the shop, you're going to do the inverse of squaring, which is to do the square root. So a is now the square root of 7,515.34. Put that in the calculator and that should give you 86.69 meters. So it means Tia is walking 86.69 meters to the shop. Now, if you compare that distance with Liz's distance, we can see that Liz will travel a shorter distance to the shop. Okay? Who will travel to the shop first? Who will arrive at the shop first? Is going to be Liz. Because Liz's distance is 80 meters and Tia's distance is 86.69. Hello, guys. Go ahead, double tap, power tap, share the live for me, please, so we have more people joining. Part B. In fact, Liz walks at a faster speed than Tia. So if Liz is walking at a faster speed, she's already going to the shop first because she has a shorter distance. And if she increases her speed, then that means that there won't be any change. She will still reach or still arrive earlier than Tia. So you're going to say Liz will earlier than Tia. Okay, so if she increases her speed, then she's gonna arrive earlier because she's already going the shortest or traveling the shortest distance. Question 22. Equation of a circle. Easy one mark. See if you guys can spot the equation of the circle. Is it 1, 2, 3, or 4? Drop your answer in the chat. Is it 1, 2, 3, or 4? Equation of the circle. Pop your answers in the chat, please. Is it 1, 2, 3, or 4? Thank you guys for the follows and the likes and the shares. Much appreciated. Third, I'm seeing 3, I'm seeing 2, I'm seeing 1. Okay, so equation of a circle, if the center is at the origin, it takes this form, x squared plus y squared equal to r squared. If the center is at the origin, 0, 0. Okay, this is a form that it takes. X squared plus y squared equal to r squared. Now, we just looked at a circle question. Well, a cylinder question that has radius. Now, from the circle, we can see that from the center to anywhere on the edge or the circumference of the circle, that's going to be 5 units. From the center to the edge, the circumference, that's 5 units. So it doesn't matter what direction you go, that's still going to be 5 units. That's the radius. So your radius is 5. So you're just going to substitute that in the equation here. X squared plus y squared equal to 5 squared. And we know 5 squared is 25. So it's going to be the first one. Definitely. Thank you guys so much. First one. So you need to remember the equation of the circle. And you need to know how to identify your radius. Okay, this circle is coming from the center. Okay, so the radius is 5. Question 23. Similar shapes with volume and area. Okay, let's have a look. Now, when you do similar shapes, if you're finding the length scale factor, we normally divide the two sides. Yes, we do a side divided by a side. If you're doing area, it's going to be the length scale factor. I'm using LSF for short, and you're going to square it. Okay, that's for area. For volume, you do the length scale factor and you cube it for volume. Okay, so you guys need to remember this when you're doing similar shapes involving area and volume. All right, so X and Y are similar. X has a volume of 64 and Y has a volume of 343. So X, the volume is 64. And for Y, the volume is 343. Now to work out the length scale factor for X, let's do the cube root, okay? Because this is in cubic units, so you're going to go backwards now. You're going to do cube root of 64. Now the cube root of 64 is going to give you 4. And then let's do the cube root of 343. Cube root of 343. And that gives you 7. Okay? So these are the two we're working for the length. 4 and 7. Now, in order for us to find the surface area of Y, because we want area, we're going to take this 4 and 7 and we're going to square them. Okay? Let's do area scale factor. So for X, it's going to be 4 squared, 16. And for Y, it's going to be 7 squared, 49. Okay? So those are the scale factors we're working for the area. Now we're given the surface area of X. So surface area of X is 176 centimeters squared, and we need to work out the surface area of Y. Now, in order to do that, this 176 here, we're going to have to divide it by this 16 here, which is the scale factor. So we're going to do 176 divided by 16, and the answer you get, you're going to times that by the scale factor here for Y, which is 49. So that gives us 11. And then to get scale surface area of Y, you're going to do 11 times the area scale factor, which is 49. Now you could write it as a fraction if you want, no problem. There are several ways you could do the question. As long as you get the correct answer, it's totally fine. So this is 539 centimeters squared. Thank you guys so much for the likes and the shares. Much appreciated, guys. Okay, so you need to remember these 3 things here. Once you find the length scale factor, to do area, you square it. To do volume, you cube it. Now, you already got the volume for X and Y. So you're going to do the inverse here, which is to do the cube root. So once you have the 4 and the 7, those are for the length scale factor. Then you need to work out the area scale factor because you're going to have to work out the surface area for Y. So you're going to square those. 4 squared, 7 squared. And then you divide the 176 that they gave you for X, divide it by the 16, because that's the scale factor for X. And it gives you 11. And 11 that you got, you multiply it by the area scale factor for Y, which is 49. Thank you guys so much for the likes and the follows. Much appreciated, guys. Question 24. A tank is a cuboid measuring 50 centimeters by 35 by 20. So we have a cuboid here. And we have dimensions 50, 35, 20. Okay? And these were rounded to the nearest centimeter. Okay, so this is a bit of error interval involved. These were rounded to the nearest centimeters. So they could be any number before. Okay, so it could be a decimal number, anything before. So let's work out the volume using those rounded numbers. So the volume is going to be length times width times the height. That's 20 times 50 times 35. It doesn't matter where you put the numbers. You still get the same answer. Multiplication is commutative. So when you do the volume for that, punch that on the calculator. And that's going to give you 70, 35. Okay, so that's 300 or 35,000, should say. 35,000 centimeters cubed. So that's the volume of the cuboid. Now, a container has a capacity of 34 liters. And it says 1 liters is 1,000 centimeters cubed. So this 35,000 centimeters cubed here is the same thing as saying 35 liters. Because for every 1,000 centimeters cubed, it's the same thing as 1 liter. So you have to convert it to liter so you can compare it with the container. So this is the cuboid. And then the container now has a volume of 34 liters. Okay? Now, the question asks, which has the greater capacity? Now, this is the tricky part of it. This sentence that I underlined here, this is a sentence that makes the massive difference. Okay, so be careful. Remember, this 20, 50, and 35 was rounded. Okay? These are rounded numbers, so they could be any number above 50, 35, or 20, or below. So the fact that we don't know exactly what those numbers were before they were rounded, there's no way I could go ahead and tick the tank, which is a cuboid. Okay, we'll be tempted to tick it because it's 35 and this is 34. But because these were rounded, okay, it's impossible to tell. So these numbers, if I write down the error interval, they were rounded to the nearest centimeters. So for 50, 50 would have to be, if it's near a centimeter, greater than or equal to 49.5. And this is less than 50.5. That will be the error interval for the 50 centimeters. For the 20 centimeters, if it's rounded to the nearest meter, then this is going to be 19.5 to less than 20.5. And then for the 35 centimeters, it could be greater than or equal to 34.5 and also less than 35.5. Now your measurements could be anywhere in these intervals. So we don't know exactly. So you cannot tell. Usman, not everything is applicable to whatever field you're going to go into. If you're going to do stuff like engineering and stuff like that, being architect and stuff like that, yeah. Certain maths will be applicable to what you're going to be doing after GCSE. You're learning it, so it helps to develop your brain, so you become a critical thinker, okay? That's the whole purpose. And then, of course, if you're doing a topic that you find that you probably like, then you can change your mind. Who knows? You probably end up in a different career than what you want to do now. All right, 25. The Venn diagram shows some information about 150 students. That's the universal set, 150. Everything inside the box, the rectangle. C is the number of students that studies chemistry. P is the number of students that studies physics. Okay? The probability that a physics student chosen at random also studies chemistry is 5/12. One of the 150 students is chosen at random. Work out the probability that the student does not study either chemistry or physics. So this Venn diagram question has some algebra in it. So these are like the grade 7 to 9 questions on the higher tier. Okay? This is higher, guys. It's higher. So this has algebra in it. All right. So let's work out the total for physics. So let's do the total for each of them. So for physics, the total is going to be all of this circle here. X plus 35. Okay, that's physics. And for chemistry, it's going to be X plus 47. So chemistry is going to be overlapping with the X. Those are the total. Okay? Now, let us work out the probability, or write down the probability, should say, that a physics student chosen at random also studies chemistry. Okay? So we're looking at the intersection here. This is what we're focusing on, that X. That's the intersection that we're looking at. If you pick a physics student, okay, and physics is X plus 35, that's the total. You're picking a student that studies chemistry also, then it's going to be X. So the probability of physics and chem is going to be X over the number of physics students, because you're picking a physics student. So it's going to be X plus 35 at the bottom. Okay? That's the probability of physics and chemistry. So you need to use X plus 35 at the bottom because you're picking a physics student. Okay, and they told us that that probability is equal to what? 512. Here. So let's write our equation. Okay, that's the probability. Let's do the equation now. So it's going to be X over X plus 35 equal to 5 over 12. That's what the probability is. All right, so the equation, now because it's a Venn diagram and you have algebra in it, we went ahead and wrote down the total number of students who did physics and chemistry. That's the first thing you do. So the circle in green, that's 35 and X. So you do X plus 35 here. Chemistry is 47 students and X plus 47. Now the question says here, the probability that a physics student chosen at random also studies chemistry. So if you're picking a physics student, then X plus 35 is going to have to be your denominator in your probability. X plus 35, the denominator in the probability. And if you're picking a student that studies both of them, then you're choosing from the X here. So you put X on top. And they told us that that probability is equal to 5 over 12. So you equate it to 5 over 12 to get the equation. Now we're going to solve for X. So to do X, to get X, you're going to cross multiply. All right, let's cross multiply. That with that, that with that. So X times 12, that's 12X. And then you do 5 multiplied by X plus 35. So this is 12X equal to 5X, expand the bracket. And 5 times 35 gives us, how much is that? 175. Let's solve for X. All right, minus 5X on both sides. Inverse. So 7X is equal to 175. Now to get the value of X, you're going to divide both sides by 7 and x is now 25. So that's the value of x. So if x is 25, let's clean up the Venn diagram, input some values. So that's 25 here in the middle, which takes us to the last sentence. One of the 150 students is chosen at random. Work out the probability that the student does not study either chemistry or physics. So if the student is not studying chemistry or physics, we're looking at this child out here, y, the one on the outside of the circles. Okay, so let us find the value of y. Now we want the probability of y. So to get y, let's work out y first. Remember, this is out of 150. 150 students, that's universal. So 150 is going to be 150 minus what we have in the circles here. 47, 25, 35, because we found x to be 25. So add those, 47 plus 25 plus 35. Take them from 150. And then that gives you the number of students who does not study chemistry or physics. And that will give you 43 kids. 43 students who doesn't study. Thank you, Nice, for the finger heart. Much appreciated. So 43 kids. So let's do the probability now. So the probability is going to be 43 over the total, which is 150. Okay, that's your probability. 43 over 150. So this is for 4 marks, guys. Thank you guys so much for the shares and the follows and the likes. 43 over 150. Question 26. And we have one more after this one. A curve has equation y equal to 4x plus 5x plus 3. How do you find revision for this topic? This is AQA. Just go on the Maths Genie website and you can look up probability, the harder probability questions, and with Venn diagram. Look at Venn diagram, probability. So we are going to show that the curve and the line have exactly one point of intersection. We're not using the graphical method. So whenever you find solution for a quadratic, you can factorize using 2 brackets. You could complete the square. You could use the quadratic formula. Okay? But for the sake of practicing, I'm going to use completing the square because we've never done that on any of the lives before. So I'm going to use the completing the square method. But you could use the quadratic formula, or you could do the double bracket formula method. Okay, but you still get the same answer. So let us go ahead and use the completing the square. That's what I'm going to use. Now, if these two are intersecting, then it means that they're going to meet at 2 points. Okay, so we have the quadratic, and then we're going to have the linear, and they're going to meet at 2 points. But this says we need to show that it only has one point of intersection. So a standard quadratic and linear graph would look like this. So if we're trying to show that this has one point of intersection, then it's probably going to look like something like that. Something of the sort. Okay? Yeah, you could use the discriminant method too when you use the quadratic formula. But let's do completing the square. That's the method I'm going to use. Okay? So if these two are intersecting, then wherever you see y in your quadratic, you're going to replace it with x plus 2. So the equation is going to be x plus 2 is equal to 4x squared. Let me put it the other way around. It doesn't matter. Let's put it the other way around. 4x squared plus 5x plus 3 equal to x plus 2. All right? Let's equate that or make that equal to 0. So we're going to carry over this x and carry over this positive 2. Let's carry them to the next side. So we're going to minus x and we're going to minus 2. Now that right side of the equation is now equal to 0. And 4x squared stays the same. This is 5x take away x, so that's 4x. 3 take away 2, that's 1, positive 1. All right? We're going to do completing the square. This is just one method. Of course, you can use others. All right? So when you complete the square, if the coefficient is more than 1, you're going to have to factor out. So let's factor out the 4. So we're left with x squared. Let's factor out the 4 from everything there. So we're going to have 4, open bracket, x squared plus x. And this now becomes 1/4. Okay? Because a quarter times 4 gives you back 1. Okay? So this is 1/4 now. And that is equal to 0. Okay? A quarter times 4 gives you 1. So when you factor out 4 from the 1 here, it leaves you with quarter. Okay. Now, let us focus on the brackets. So the coefficient of x, we're going to divide that by 2. Okay, let's divide the coefficient of x by 2. So we're going to do 4, open bracket. And inside your bracket, you only put x and not x squared. Okay, because we're trying to find the perfect square. This coefficient of x is 1. Here, it's 1. So we're going to divide 1 by 2, which gives us half. So this is a plus half. Close the bracket, raise that to the power of 2. So that's your perfect square, x plus half, all squared. Now for this part here, you're going to carry down your quarter. So bring down the quarter. And you're going to subtract the square of half from that. And that is equal to 0. Why are we dividing by 2? Because we're trying to find the perfect square. The closest perfect square to this quadratic. This is the completing the square method. If you have never done completing the square before, yeah, it's going to be a bit confusing. All right, so now let's tidy this up a bit, simplify some more. I'm using this method because we haven't done any past paper with completing the square on it. We've done quadratic formula. We did factorizing using the double brackets. We've never done completing the square, so that's why I'm doing this one. So we have 4 in brackets. We're going to have x plus half. That stays the same, all squared. Then now we're going to simplify this bit here. This quarter plus half squared. Let's simplify that. Minus half squared, which is half times half. So that's actually a quarter, take away a quarter, which gives you 0. So all of that blue box there becomes 0. And in that case now, if you're going to write down the solution, okay, of the point of intersection, here you can just divide through by 4. So you can just divide everything by 4 and it still gives you 0 over there. So this is actually x plus a half, all squared equal to 0, which means x is going to be negative half. The negative of this inside the bracket, negative half, with no other solution. Okay, so if you did the quadratic formula, you'll still get the same answer. Okay, x is negative half. If you use the double brackets, okay, you're still going to get negative half. But I chose to use the completing the square because we haven't done any question like this. All right, guys. So that's, is this calculator? Yes, it's calculator. So you can put it on the calculator. But sometimes you'll get non-calculator question with completing too. So you could put these fractions here on the calculator and it will give you 0. All right, question 27. We're going to prove algebraically that 2.75 recurring converts to fraction 124/45. So this is recurring decimal. This comes only on the higher paper, okay? Now, there's a video on my profile with recurring decimal, how to do that. So if you want to go back after this, you can go back and have a look at the video, okay? That will help. But we're going to do this one. So the recurring decimal here is 2.7555, any amount of fives behind it. Doesn't matter. Okay, let us call that x. Because it says to prove algebraically. So we're using x. How much is left? I think one more question after this. 28. Yes, 28. And then we're finished. Prove algebraically. So x is 2.755555 recurring, any amount of fives. So when you're doing it algebraically, you always multiply by powers of 10. So I'm going to start with 10, then I do 100 and see where that takes me. So let's do 10x first. We times by 100. Times by 10 here. So if I multiply by 10, I'm just going to put in the arrows so everybody can see what is happening. You don't have to put the arrows in when you're doing it. So if you times this by 10, that becomes 27.555 recurring. Okay? Now, the aim is to get the recurring digits to be the same. That's the only way you're going to get rid of the decimal. They have to be the same digits behind the decimal point. But if you look at these two, we have 7555 and we have 555 here. They're not the same. So you're going to go back in again and multiply by the next power of 10, which is 100. So let's multiply by 100 or 10 more. Okay. So to go from here to here, you times by 10 more. All right. And if you multiply that by 10, now we're going to have 275.555 recurring. Now, if you look at those two, you can see that these have the same digits behind the decimal point now, 10x and 100x. So those are the two you're going to subtract to get rid of the decimal. So you can write the fraction. So we're using 10x, 100x, it doesn't matter how many fives you put there. Okay, you can put any amount of fives behind the decimal because it's recurring. So if we take away the top from the bottom, we have 90x. And the 0.55s, those are going to disappear. They're going to cancel out because they're the same. It's going to become it's going to be no more decimal values. No more decimal digits. So we're going to do 27 from 275. Now, if you do 27 from 275, you're left with 248. So 90x is equal to 248. Now, to get the value of x, you're going to divide both sides by 90, okay? Divide by 90 on both sides. And we can see that x now is 248 over 90. And then now you're going to simplify that fraction. It ends in 0 and 8. We can divide it by 2 top and bottom. So your simplified fraction is 124 over 45. Okay, and that's it, guys, for 3 marks. 3 marks. This is how you'd prove algebraically that you get the same thing in the question. Thank you guys for the likes. 3 marks. Thank you guys so much. We're up to 20K likes. All right, the last question, grand finale. Okay, so this is functions, composite, inverse. All right, let's have a look at question A. It says, the question says the function of x is 5 minus x, and f of x is 5 minus x, and g of x, which is also a function, is 3x plus 7. We're going to simplify f of 2x plus g of x minus 1. Let's go ahead and substitute, guys. Now, if you look at both functions at the top and what we have in the question, we can see that our x here is the same thing as our 2x in the question. And our x in the g is the same thing as x minus 1. What that means is that in your function, wherever you see x, you're going to replace it with x minus 1 and 2x for the f function. So let's go ahead and substitute. So f function, 5 minus x and we're going to multiply that by 2. Just a second. Let me double check that one. Okay. All right, you're replacing. So it's just 5 minus 2x. 5 minus 2x. So you're taking out the x here and you're replacing it with 2x. That's what it is. All right. Next, we're replacing this x in the 3x with x minus 1. So that's going to be plus 3 in brackets, x minus 1, and then you put plus 7. All right, let's go ahead and simplify. So that's 5x minus 2x stays the same. 3 times x is 3x. And 3 times a minus 1 minus 3 plus 7. Okay, further simplify it. We have a negative 2x plus 3x, that's x. And 5 take away 3, that's 2. 2 plus 7, that's 9. So this is x plus 9, guys. X plus 9. So again, wherever you see x, you replace it with 2x. Let me put it the other way around. And wherever you see x in the g function, you replace it with x minus 1. Okay, part B, inverse. So we need to solve. So before we do the solving, we need to find the inverse of the g function. So the g function, g of x, is 3x plus 7. 3x plus 7. G of x, the function of x, is the same thing as y. So you just write y equal 3x plus 7. Okay? So now we're going to make x the subject. So we're going to minus 7, and then we divide by 3. divide by 3. So x is y minus 7 over 3. And then now you're going to swap x with y, because you're doing the inverse. You're going to swap x and y now. So y is going to be equal to x minus 7 over 3. Okay? Which means that g, the inverse of g, is x minus 7 over 3. That's the inverse we just found.